Welcome back to my chemistry lessons. Today we are going to see what are the energy sublevels. The last time uh, we went through what are the energy levels, and on close examination of the bands of light in emission spectrum can be seen to consider two or more lines are very close together. This suggests that the main energy level may be split into energy levels of slightly different energies called sub-energy levels, or for time being we can call it as orbitals. So these sub-energy levels can be denoted as small letters S, P, D, F. So S sublevel can hold 2 electrons, and P sublevel can hold 6 electrons, and D sublevels can hold 10 electrons. So that means only one S sublevel or S orbital, and P means there are 3 P orbitals, there are 3 types of P orbitals. So each P can accommodate 2 electrons, so total 6 electrons. So D, there are 5 D orbitals, and each D can accommodate 2 electrons, so 5 by 2, 10 electrons. So that's where we can say S sublevel can hold 2 electrons, and P sublevel can hold 6 electrons, and D sublevel can hold 10 electrons. So the number of sublevels in the main energy level is same as the number of that level. So for example, n is equal to 3, that means that indicates M shell has 3 sublevels. So small n is equal to 3, that means it is M shell, and that M shell can have 3 sublevels. So that may be 3s, 3p, and 3d. So here n is equal to 3, so that will be M shell, third energy level. So the sublevels are 3s, 3p, and 3d. So S can hold 2 electrons, P can hold 6 electrons, and D can hold 10 electrons. And there is another concept is a dual nature of electrons. So electron, we all are thinking that electron has only particle nature, because in our concept electron has a solid nature. Electron is like a solid body. But here, according to Heisenberg uncertainty principle, we reach a conclusion like electron has a dual nature. One is wave nature, and other is a particle nature. So electron can have both nature, a wave and particle. So another important point, that supports the wave nature of electron supports that it does not travel on a fixed path at a definite distance from the nucleus. So it is not, the electrons from the nucleus into a particular distance is not traveling like on a fixed path. It shows some wave nature. That means that travel shows a wavelength as well. So according to Heisenberg uncertainty principle, it's impossible to measure at the same time both the velocity and the position of electron. So that concept brings idea of the dual nature of electron. And the next thing we're going to discuss is atomic orbitals. What are the atomic orbitals? As I mentioned before, the sublevels is pretty much resembles with the atomic orbital. So according to Erwin Schrödinger's mathematical calculation, orbital is a region in a space within there is a high probability of finding of electrons around the nucleus. So you probably remember that in a two-dimensional concept. So there is a central part, rigid nucleus. Around the nucleus there are certain levels, and those levels are called orbits, not orbitals. But here, according to three-dimensional concept of an atom, So here there is a maximum probability region for finding of electrons around the nucleus is called orbitals. Those called atomic orbitals. So there are s orbital, p orbital, g orbital, f orbital, etc. So s orbital have always spherical symmetrical shape, and p orbital have tumble shape. So here you can see the shapes of two kinds of orbitals. There's a one s orbital. That means there is only one s orbital here, and that s orbital oriented along the three axes equally, x, y, z. But if you go to p orbital, the orientations are different, but they have same energy. But one is along x-axis called px, another one is along the y-axis called py orbital, and the other one is pz, because the orientation is along z-axis. So that's why we call them px, py, pz. So another important point, what are the difference between orbit and orbital? Orbit is a definite circular path around the nucleus. At the same time, orbital is a maximum probability region in space to find electrons around the nucleus. And orbit is a two-dimensional concept, and orbital is a three-dimensional concept, because we can explain the position of that orbital or orientation of orbital along x, y, z axis. So it's a three-dimensional concept. And third point is orbits are circular in shape, but at the same time orbital have different shapes. S orbital has spherical symmetrical shape, and p orbital has tumble shapes. And the fourth point, maximum number of electrons in an orbit can be calculated by the equation 2n square. N is an integer, is equal to 1, 2, 3, 4, etc. That indicates energy levels. N is equal to 1 means first energy level, N is equal to 2 means second energy level, etc. At the same time, orbital, each orbital can hold two electrons with opposite spins. That's important point. So the electrons must have opposite spins. The electrons must spin in opposite directions. So these are the points about orbit and orbital. And thanks for watching. God bless.